The third and final method that we're going to go over is the square root method. And so here it says the solutions for a quadratic equation of x squared equals c are plus or minus the square root of c. So what we need to do is we need to isolate the x squared, and then we'll take the square root of both sides. So here, this is already isolated. You have x squared equals 121. So we will take the square root of both sides. Now, this is the shortest and the easiest method. It's also the method that we can use the least amount. So that kind of sucks. But we do need to, I don't know, pay attention, be aware that we still get two answers because this is x squared. So a lot of times we'll say that x equals 11, and you're missing out on one of those other answers. That's only one of two. And I think the reason is a lot of times when we put that into even our calculator, the square root of 121, perfect square, it tells me it's just 11. But we need to remember that this is plus or minus the square root of c. And so that's where my second answer comes from. Okay, I'm not going to do this for all of these, but you can graph it and you can see this. X squared, we'd have to subtract that 121 over minus 121. And I'm going to change my window since I know it's plus and minus 11 to negative 15 to 15. And then I'll change this back to negative 10 and 10. And there are your two negative 11 and positive 11 x-intercepts. And you can also think about it like this. If you plug in 11 here, 11 squared is positive 121. But if you also plug in a negative 11, you still get a positive 121. So they both work when you substitute them back in. Okay, so let's use that to kind of go forward here. Part B, we have x squared plus 45 equals 0. So the first thing I need to do is isolate and get this x squared portion by itself. So we need to subtract that 45 over. And so we get x squared equals negative 45. And then we're going to take the square root. And I probably should have even talked about this here, but we take the square root because that's the opposite operation, right? So the opposite of adding is subtracting. So that's why this plus 45 gets subtracted over. The opposite of multiplication is division. And the opposite of squaring x is to take the square root. So I'm going to take the square root. And we get x equals plus or minus. And now I need to simplify this. So if I come over here to the side, the square root of negative 45 is going to be 45 and negative 1. So here's my I. And we did say here, I didn't read the instructions, but it does say here that we could get complex, which complex are your imaginary. Now let's break down 45, and that's 9 and 5, which is 3 and 3. So here's my pair. So this is going to be 3i, and then what doesn't have a date stays inside. And so that is my answer. Those are my two solutions. And again, I'm not going to graph the rest of these, but you can graph this. And because you have an imaginary, what does that tell you about its graph? That tells you that there are no x-intercepts. So it should either be all below or all above that x-axis. C, same thing, isolate that x squared. So to isolate that, the first thing we would do is add that 40 over. I still have not isolated that x squared, so I cannot take the square root yet. Now we need to divide this 2 over. So I've got x squared equals 20. Now I can take the square root of both sides. I'm going to get x equals plus or minus, and then we need to come over here to the side and break down 20. 20 is 4 and 5, which is 2 and 2. So your 2's come out, and your lonely 5 stays inside. So you can graph this and then use your trace feature to see if 2 square root 5 and negative 2 square root 5 are your x-intercepts. Now D, E, and F look a little bit different, but there is a note down here, and it says, note this method can be used to solve equations of the form ax plus b quantity squared equals c. A lot of times when we get questions like this, you guys will expand this out to x plus 1 times x plus 1, FOIL it, and then subtract your 18 over and use the quadratic formula. Don't do that. Still isolate the squared component here, which it is. You have just the squared equals 18. To get rid of the squared, the opposite operation is to take the square root. So now the square root and square cancel, and I am left with x plus 1 equals plus or minus, and let's break down the square root of 18. 18 is 9 and 2, which is 3 and 3. So your pair of 3's come out, and this 2 that doesn't have a date stays in. Now I am not done, because now I need to solve for x. So to solve for x, we're going to subtract this 1 over. So when I subtract 1 over, we now get x equals, you can write this, I'll just go ahead and do it. So these are not like terms, and so we can write this as plus or minus 3 square root 2 minus 1. I personally do not like this as my answer. I always like my square root to go at the end, because if this gets sloppy, it's hard to tell, is that negative 1 under the radical or outside of the radical. So for me personally, I like this plus or minus to go at the end. So I'm going to write my answers as negative 1 plus or minus 3 square root 2. So you can again graph is negative 1 plus 3 square root 2 and negative 1 minus 3 square root 2, your x-intercepts. So on part E, this one already had that squared component isolated. It's not isolated here. I have my squared component minus 11. So the first thing I need to do is move that over. And so we will have x plus 5 quantity squared equals 11. Now I can take the square root, which will cancel out the radical and the squared. So I have x minus 5 equals plus or minus, and then simplify if you can. This one doesn't simplify though. When you do the square root of 11, that's a prime number. That's only 1 times 11. I don't have a pair of anything to come out. And in fact, if I even had something like, if I was trying to simplify something like the square root of 6, the square root of 6 isn't prime, but the only way to break that down is 2 and 3. You don't have a pair of anything to come out. So this is simplified. Same thing with like something like the square root of 14. That's only 2 times 7. I don't have a pair of anything. The square root of 14 is prime. So, or is simplified. So if you either have a prime number, or when you break it down, you don't have a pair of anything, you can't break those down, and that's okay. So this is just the square root of 11. And then lastly, to get x by itself, we'll add that 5 over. And so we get x equals 5 plus or minus the square root of 11. And again, you can put that in your graph and check it. Then lastly, why don't you guys try actually pausing this video and trying to do F on your own. Okay, I hope you have had a chance to pause the video so that you can try part F on your own. Let's go through it and check your answer. So first thing we need to do is get that squared by itself. So we're going to move that 24 over by subtracting it. So I've got x plus 3 quantity squared equals negative 24. Now that the squared's by itself, the opposite of squaring is to take the square root. So I have x plus 3 because the square root and square cancel, plus or minus, and then let's break down negative 24. This is 24 and negative 1, and negative 1 is my I. So we have an imaginary, and then break down 24. This is 8 and 3, which is 4 and 2, which is 2 and 2. So I have a pair of 2's, and I have this I. So this is 2 times I on the outside. And then I have a 3 and a 2 that are going to stay inside, and they're going to get multiplied back together. So this is 2I square root 6. And then lastly, subtract the 3. So x equals negative 3 plus or minus 2I square root 6. And for the last time, you can check this in your graph. While you cannot check if this answer is correct, what you can do is look at the graph and make sure you should get an imaginary. Because it has an I in it, that means it should not have any x-intercepts. It should be all above or below that x-axis. And I was about to stop it, but before I do want to reiterate what I said at the end of one of my other videos, if I haven't already lost you. And say again that this is a really, really important lesson going forward, not just for the remainder of this class, but for the rest of your classes going forward. You're going to need to know how to solve quadratics by factoring, quadratic formula, and by square root method going forward into trig, into your calc sequence, and on beyond that. So you really, really, really please take the time to learn this now before you need it in other classes.